So welcome back, guys, and I'm sorry you're not here, but we can still do some good physics. We've been looking at how heat transfers, how you can get heat from one place to another, and I'm hoping you have a good understanding now of conduction of heat, how you can get heat to pass through a solid, particularly in a metal. But what I want to look at today is how would you get heat through a liquid or a gas? That's something that can move around. So what we're going to look at today is convection of heat, and I've got a really nice little experiment to show you before I do the teaching on the board. Okay, so here's an experiment I would have shown you if you were here. I've got a beaker full of cold water, and this is potassium permanganate, which is basically kind of like purple dye for us as physicists. I'm sure the chemists get more excited about it. So I'm going to take a little bit of this and I'm going to drop it into the beaker of water. So it's really pretty, and I hope you can see the purple dye's gone to the bottom. Then what I'm going to do is light a Bunsen. So I need to go over here, let the air come out of it, still full of air. There we go. There's our Bunsen lit up. Okay, and then I'll get out of the shop, and what I'm going to do is put it on a roaring flame, and I'm going to put it underneath the beaker, and I want you to watch the purple dye very carefully. The beaker will cloud up a little bit, but here we go. So let's put it underneath and heat the bottom. And there you go, look at that. Look at that. Look at the purple dye rising up. And it's going up to the top of the beaker. And then it hits the top. And then some of it you can see folding down the side again. And if I add more heat, rising up. After a while you don't get to see much because the whole thing's full of the purple dye. But what you're seeing there is an effect called a convection current. I'll just turn the Bunsen off. So, the purple dye made you see the water, and when we heated the water it expanded and it rose up through the beaker, taking the purple colour with it, and most importantly it was hot water rising, so the hot water went from the bottom to the top, took heat with it, so you've seen heat now moving through a fluid. Once it cools down, down it goes again and gets heated back up, and we get a convection current forming in the beaker. I absolutely love doing this experiment, and when you guys are here, I hope one or two of you will shout out what you recognise. Oh, it looks like a mushroom cloud. Oh, it looks like a volcano. Maybe it looks a little bit like the water kind of bubbling around and rising in a kettle. Or even more strangely, when you look at the top of a hot car bonnet or a radiator on a hot day and you look across, you see this sort of shimmering. You get it on a hot road as well. And what you're seeing there is hot air rising. So that was our potassium permanganate demonstration to show convection currents in a beaker. Right, here's the second experiment I'd show you if you were here. I hope you can see I've got a sort of square, sort of ring-shaped test tube here. It's a really weird test tube because it goes all the way down, all the way around and back again. And there's a little bit here where it comes up and it's open to the atmosphere at the top. And I'm not sure if you can see just there and below, the whole thing is full of water. So what I'm going to do is I'm going to get a funnel and stick it in the top like that. I'm going to tip in a little bit of the purple dye, the potassium permanganate, and let's have a look. Get that in. It's always a bit fiddly, this. There it goes. Okay, take the funnel out. Right, so we've got some of that purple dye sitting at the top there, and what I'm going to do is I'm going to heat the bottom of the tube here. So maybe you should pause the video now and think, what's going to happen to that purple dye if I put the Bunsen under this corner and heat that bit of water? Okay, so you're ready. So I've got to light the Bunsen, so I'm over here. Right, there goes for the Bunsen. So I'll get a little bit of a hotter flame. I'll go off camera now, take a close look at the purple dye, and I'm now going to heat this corner here. Quite gentle heating. Take the Bunsen away a bit, heat a little bit more. Keep watching the top up here. There you go, look at that. Look at it coming down. So there's the purple dye convecting round. And if I'm quick enough, I can heat this corner. I might not be quick enough, but let's heat this corner. Oh, I think not quite been quick enough. It'll go if we give it a bit of time. So I'm now heating this corner, and think about what's happening to the liquid here. And watch this, watch that. You should see all the purple dye now retreating back the other way. It's a lovely little experiment, this. So what you're seeing there is a lovely convection current. Did you explain it to yourselves? Could you explain it? So in other words, we heated here, the clear water expanded as it got hot, took the heat with it, and as it went round, dissolved some of the potassium permanganate and took that around. And then I tried to catch it out. I got onto this corner, heated this bit, made this bit hotter. It expanded more. This started rising, and the convection current went in the opposite direction. Now, there's one other thing that's worth mentioning. The water in here is now quite a bit warmer than it was, so the whole tank has expanded slightly. And that means that we have to be open to the atmosphere here, because we wouldn't want it to try and expand and explode the glass. And the level here, if we warm it a bit, should rise slightly. That's not convection, that's actually the volume of the liquid getting slightly bigger as it expands. So that's all I tend to do with this apparatus. But some teachers might take it a bit further and say, if this is a house and we have our downstairs here and we have our upstairs there, do we need a boiler downstairs and upstairs? Well, no, we don't. If we were to heat the water downstairs in the house with a boiler, then assuming we're not in a mad hurry to get hot water in our radiators, if we can heat the water, it will begin to expand and it will rise and create a convection current. And look here, the cold water will come back downstairs and go back to the boiler to be reheated. These methods are used in some power stations, particularly nuclear power stations, for cooling, that you can get a convection current building up in them. In other words, you can stir the coolant without ever needing a pump to drive it around. You'll still get convection. So there was no pump in this system, just the hot fluid rising and taking the heat with it. Okay, so let's try and explain what happened in that experiment. So we saw heat convecting. So if you remember, that's one way heat can move from one place to another. And it was moving in a fluid. And I always say to my students that a fluid is something you can push through a pipe. So what I'm really thinking about is gases and liquids, not something that's like a bulky solid. So we're going to talk about how heat can move through fluids. So the easiest way to think about this one is to think of a beaker of water, and you've got to remember that in the water the particles are free to move around. So there's molecules of water in here and they're free to move around within the beaker. It's the liquid that you see. And when we heat it up from underneath, so we put some heat here, we added a little bit of purple dye just so we could actually see what was happening. When you heat a liquid, the particles move further apart, as you know, and they move around faster. But if they move further apart, they're becoming less dense. In other words, more spread out. Don't say lighter, please. It's the same particles. The particles haven't expanded, but in other words, each particle hasn't expanded. It's the gaps between them that have got bigger. They've spread out from one another. Okay, and that means they're less dense. So I'd like you to think about it similar to a brick in a swimming pool. A brick is more dense, and a piece of foam rubber in a swimming pool floating on the surface, that's less dense. So here we go. We've got our heated up water here, which is expanding and becoming less dense, and it's surrounded by water that is more dense because it's cold. So like a less dense thing in a swimming pool, this water is going to rise. So up it goes. But when it reaches the high point up here, it's going to cool down. If it cools down, it's going to shrink, in other words, contract. It's going to become more dense again, and it's going to fall down to the bottom. So here we go. There it is, falling back down to the bottom of the beaker. So it's really important you understand with this physics that it's happening in a fluid. In other words, this can happen in air as well. If you heat air above a radiator, that air will expand and rise. Now look, the heat doesn't rise. Don't ever say that the heat rises. Heat doesn't feel the gravitational field. It doesn't know up, down, left and right. What's rising is the fluid taking the heat with it. And when you get asked about this in exams, they're really keen that you draw a diagram like this one, and you use the important term for what's going on in here. What we've got is a convection current. Current means these sort of rings that we're getting, and that will go on and on and on forever as long as there is a temperature difference between the bottom here and the top. Okay, you know all of this. You've seen it lots of times at home. Where do you put the heater in a kettle? You put the heater at the bottom, so you don't need to stir the water to heat it. In other words, the water warms at the bottom, convects upwards and stirs and makes sure that all the water in the kettle gets warm. Have a think about, it sounds obvious, you put a saucepan when you're making pasta on the cooker and you heat it from underneath. And the example I sometimes set for exam questions and things is, where would you put a heater in a tropical fish tank? Well, if you think about it, if you put it right up at the top, you'll only heat the top bit of water. And if you put it at the bottom, the convection currents will help make all the water warm. The final one is quite an interesting example. Some houses have a tank in the house, and that tank is your hot water tank. And you can have electrical heaters in that tank, and if you have an electrical heater in there at the bottom, if you think about it, it'll heat the water here and it'll convect upwards, and the whole tank of water will get hot, but it'll take a long time to heat all that water. But if you have a second electrical heater near the top, that will only heat this bit of water, and it'll be a much quicker process. But remember, you can only take the water off here to have a quick shower or a bath or something, and then you'll be back onto the cold water. So this has the effect of a small amount being heated quickly, and this has the effect of heating it all. This one usually takes about an hour, and this might be 15 minutes or something like that. So I hope you have a really good understanding now of convection. I'll put some links into other videos I've done on heat, and do have a look at those, and give some thought now to, could you explain convection to someone else? Because of course when it comes down to it in exams and things, you're going to have to explain convection. Anyway, hope you get on well with that, and I look forward to seeing you next time.